Welcome back. I'm going to pick up with number 12 here in my solutions to the practice problems for exam 2. 12 and 13 should be pretty fast. These are derivatives of natural log functions and exponential functions. They are compositions, so we have to follow the chain rule. But in general, they go pretty quickly. So I'm going to say a little bit about number 12 here before I run through the derivative, just to show you that there's a shortcut. I want to remind you about it. So here's our function, and this is a composition. So we really have to follow the chain rule, which basically means we do our derivative rule first for the natural log, which is going to be 1 over that stuff in the parentheses. Sometimes I call that the original. So 1 over the original, which the original is 5x cubed plus 13x. Lots of students put 1 over and then immediately do the derivative. Do not do that. Always write the original first. Using the chain rule, we multiply by the derivative next. The derivative is going to be 15x squared plus 13. So that's the actual derivative there. But typically what we do is simplify this a little, and we multiply that quantity on the side there times the 1 and put it in the numerator. So this ends up being 15x squared plus 13 over 5x cubed plus 13x. Now, a shortcut that I like to use is I just simply recognize that this is the derivative of the stuff in parentheses, and this is the original stuff in parentheses. Got to spell that right. And so my shortcut to you is when you see a function like this, you can just skip right to the answer because you know it's always going to be derivative over original. So the derivative of 5x cubed plus 13x is 15x squared plus 13. The original is 5x squared plus 13x. So please feel free to use that shortcut. That's just like a verbal model there, but it really helps us remember that these derivatives are fast. It's just the derivative on top of the original on bottom, derivative over original. So please feel free to steal that as you're working through your homeworks and, of course, when you get to the exam. Now, number 13, excuse me, is even easier. We love functions that have e to the in them. So I'm going to rewrite this one here. It's e to the 2x cubed plus 8x. The whole exponent is 2x cubed plus 8x. Okay. Now, we already know that the derivative of e to the x is e to the x, so we don't really have to do anything except because this is a composition, we have to follow the chain rule. So the way I typically write this is I stick the derivative in front. In this case, it would be 6x squared plus 8. And then I just put the e to the original, 2x cubed plus 8x. And I'm done. I stop there. If you want to think of this in terms of derivative and original, it's derivative, and then e to the original. I'll put original in green. So original is the exponent. The derivative in front, and if it's a polynomial, like this is a binomial, make sure you put in parentheses. Like those parentheses have to be there. If you don't include the parentheses, it means something else. The order of operations are different. So just remember these exponents that have more than one term, the parentheses are implied there. So we never write them, or we often don't write them, but it's implied that there's parentheses around that 2x cubed plus 8x. That derivative then will also have parentheses around it because it's a binomial, more than one term. Okay, those two should be pretty quick. I'm expecting good results on those. My fingers are crossed, obviously, because mistakes happen. But if you remember derivative over original and derivative e to the original, you'll be in good shape. I do want to take a little time on number 14. Number 14 is an application of derivatives that comes from a bigger field of study called marginal analysis. And we're just basically introducing a little bit of vocabulary in these lessons that we've done. So essentially, we're going to make a revenue function and then take the derivative, which we call the marginal revenue, and plug a value into that, right? And then talk about what it represents. So this was discussed in the lessons in the reading, but I'm going to take a little time to explain it here as well. So when you have a relationship between the price and the quantity, okay, like this right here, sometimes we call that a demand equation, but let me, yeah, so this equation right here relates the price and the quantity. That's the price. Now, revenue is how much money you're going to bring in when you sell a certain number of items. So to figure out your revenue, revenue is simply number of items times the price of each items, right? So revenue is really just P times X. And since this thing says P equals, we know what the P part is. We're just going to multiply by the X. So to do letter A, don't do anything crazy. Just make a new function where you take the one I gave you, which is negative 0.02x plus 600, and you multiply by x. Now, typically what I'll have you do is distribute that, but really that's all that you need to do. So to finish this off, we distribute the x, and we end up with 0.02. That's negative 0.02, x squared plus 600x. And now I'm done with that thing, okay? So this is my revenue function. I want to do a highlight here. This is my revenue function. I took the P, which is actually right here, right? Negative 0.02x plus 600, and I multiplied it by x. That's the P. Let me fix my arrows here a little bit. I'll make them a different color too. This thing is P, this whole thing. This is P, and then x is just x. So I take the equation, I multiply by x. Now I've got my revenue function. Whenever you see the word marginal, that means derivative. So when it says find the marginal revenue function, you're going to find the derivative of that thing. So my marginal revenue function is just going to be, I bring the 2 down and multiply, so negative 0.04x plus 600. That's my revenue function. Excuse me, that's my marginal revenue function, r prime of x. And when you're writing it, go ahead and put the r prime of x in front of it and the r of x in front of it so I know what function you're actually calculating there. Okay. Part C, we're just going to do a quick calculation. We're going to do a marginal revenue calculation. We're going to plug 1,000 into our function. So for letter C, I'm going to do r prime of 1,000. In other words, I plug in 1,000 where x is. So multiply by 1,000 here. I'll add in the 600. I've already done the calculation. And if my calculation is correct, that's $560. Remember, this is a revenue function, so the result comes out in dollars, okay? So my marginal revenue at the production level of 1,000 is $560. Now, here's the thing that I want to take a little extra time to explain because it may not have been clear from the reading and the practice problems that you did. So once I've found this value of $560, I need to know what it means. And these marginal revenue functions, they actually tell us the price. So it could be a cost, like the cost of a thing, or in this case, the revenue. But they tell us the price for the next item if you produce and sell it. So what this answer in letter C represents is that when we sell, when we produce and sell, item 1001, so the 1001st item, it will bring in an additional $560 in revenue. So it might be beneficial to make another item and sell it because we're still going to bring in $560. Now, the bigger picture here is revenue is just one piece of the puzzle. We also have costs, and you'd have to subtract off the cost to see if you still have profits coming from that. But in terms of this question, when you plug in 1,000 and you get an answer of $560, it means that the 1,001st item would bring in $560 of revenue. This question was actually about selling cell phones. So if I made that 1,001st cell phone, it alone would bring in $560 in revenue. Okay, that was this was number 14. I didn't label it here, but this is number 14. And so that was this 11 through 14? 12 through 14. So we did 3 more problems here. I squished them in a little, but hopefully these explanations helped. And obviously you can review my solutions document as well. If you have any questions, let me know before you take the exam. I'm going to keep saying that. But in the meantime, take care. By the way, I'm going to put 15 and 16 in their own little video coming up next. So in the meantime, take care.